So today you're just going to do a quick lesson on the distributive property. You may or may not have heard of it before, but I assure you that by the end of this, you'll have it just fine. So if you were to see something that looked like this, and you were asked to evaluate it, 3 times the quantity 4 plus 2, you might say, well, because of the order of operations, 4 plus 2 is within those grouping symbols, so I'm just going to add that first and then multiply by 3, and you'd be absolutely correct. If you use the order of operations, you would say, well, 4 plus 2 is 6, and I know 3 times 6 is 18. And you're correct. It's absolutely right. But we also have this really fancy property called the distributive property. And the distributive property states that when we have something that looks like this, 3 times a quantity, or any number times a quantity that has an expression on the inside like this, you can say, and this is the algebraic definition, A times the quantity B plus C is equal to A times B plus, and that's that sign there, A times C. So, in this case, with 3 times the quantity, 4 plus 2, I can say, well, then that's equal in value to 3 times 4 plus 3 times 2. I've just taken the number that's being multiplied by the quantity, and I multiplied it to the first value, and I multiplied it to the second value, and then I added them because the expression inside said to add. And 3 times 4 is 12, and 3 times 2 is 6, and 12 plus 6 is 18. So I have I get the same answer. I get an equivalent solution. So here's another way to visualize the distributive property. You might be familiar with arrays. You may have done them in elementary school. You may have done them last year. But if you think about it like this, if we have 3 times the quantity 4 plus 2, well, isn't 4 plus 2 6? So if you look at this rectangle, this is 6 units. 1, 2, 3, 4, 5, 6 total. And total, this is 3 units, and we have it labeled over here as well. Well, we know that 6 units times 3 units is 18, right? But also, if we look at it like this, well, we know that 3 times 4, because this is 3 times 4 plus 2, because I've broken up 6 into 4 plus 2. Well, 3 times 4, well, that's 12, because that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 square units. And then 3 times 2 is 6 square units. And so I can say that, well, 3 times 4 is 12, and 3 times 2 is 6, and I know that 12 plus 6 is 18. So it's just a visual representation of the distributive property and how it might work. Okay? Now, what you're probably going to see most with the distributive property is its use with variables when we get to combining like terms. But, so I wanted just you to see how this works. Now, here, this doesn't have variables, but I wanted to run through it just in case. Now, if you were doing the order of operations, you would add the 6 and the 3, to get 9, and then you would multiply 2 times 9 to get 18. But with the distributive property, I can say, well, that's equal to 2 times 6 plus 2 times 3. And 2 times 6 is 12, plus 6 is 18. Okay? So that's how that works. Now here I have a variable, and I also have subtraction. Is subtraction okay? Well, yeah. I mean, and you could even say, if you're not comfortable with subtraction, you could say, well, I'm going to say, well then, let's make it 8 plus negative x. And then you can multiply it by 5. What I've just done here is I've thrown in my subtraction property, and I've also kind of done a commutative property on you, right? I mean, I changed the order I'm multiplying the expression and the number on the outside. The number on the outside doesn't have to go in front of it. It can go on the outside as well. It's still going to be 5 times 8, 5 times negative x. So 5 times 8, we can say, well, that's equal to 5 times 8 plus, and it's going to be a negative 5 times x, which is 5x. And when I have these terms, they're not like terms, and we'll talk more about that later, But this would be your solution after you would say, well, that's 40 plus a negative 5x. Okay? And you could put this in parentheses just so you know that's a negative 5x that holds that value. If I'm looking here, I don't have any whole numbers on the inside, or I don't know if I do. I don't know what my variables represent. So I just say 10 times y and 10 times z, and I just maintain that addition. So it looks like this using the distributive property. I sometimes draw arrows just to keep my brain straight. That's 10 times y plus 10 times z. And y's and z's are not like units, so I can't put them together. They're like apples and oranges. So 10y plus 10z is my solution. It's as far as I can take it. And then lastly, if I have an example like d, I can have more than 2 numbers within an expression. I can have multiple numbers. I can have a complete order of operations inside this here, and if this is being multiplied to it, I could use the distributive property. So 12 times q is 12q. And then I can say plus 12 times 2, like so. And then minus, because it's subtraction here, 12 times p. And then just to simplify it as far as it can go, it's going to be 12q plus 12 times 2 is 24 minus 12p. And again, the p's and the q's, they're not like terms, so they can't be combined. And you can't combine constants with q's and p's either. That doesn't work. So that, in a nutshell, is the distributive property.